So the general equation for a sine function is that y, or if you want to call it f of x, okay, it's equal to a times the sine of bx minus c plus d. Okay, and what we know about function transformations is that this a here is going to constitute a vertical dilation. And we're going to explore each of these in a little bit more detail in just a moment. B is going to cause us a horizontal dilation. So we're looking at compressing our function now. C here is going to be a horizontal translation. Okay, so horizontal translation for C, so moving our thing left and right. And D here is going to be a vertical translation. So that should make some sense from our function transformations sort of videos about what the vertical dilation, horizontal translation, and vertical translation all look like and what they do. We're just going to explore them now in a sine function. Okay, so let's just come down here and we'll redraw out our equation. So we've got our y equals a times the sine of bx minus c plus d. And first of all, we're going to explore what our little guy a does. Okay, now remember that's our vertical dilation. So for example, let's compare sine of x versus maybe 2 times the sine of x. So we're just changing our value of a here. We're changing a from a 1 to a 2. Well, sine of x, I know what the general shape of sine of x is. We saw that in a previous video where we kind of generated our sine function. And this is just the only bit that I want you to remember, okay, to know off the top of your head, is that a sine function looks like that. It goes from 1 to -1, and we kind of get this point here at 180 and this point here at 360 degrees. Okay, so what's going to happen? Well, I'm going to get a vertical dilation. Remember, this a guy, okay, constitutes a vertical dilation. Okay, so what does that mean? That means I take my function and I don't change its width, but I stretch its height. So I'm now running up from 2 down to -2. So this thing is going to go double the height now. Okay, so we kind of get a taller and steeper sine function running from 2 to -2 instead of from 1 to -1. But our period doesn't change. We don't change the width or anything like that. It's just the height which we're sort of we're stretching out here. So that's the impact of our constant a. Okay, of course, if a was less than 1, maybe it's 0.5, then we're going to half the size of our vertical dilation, so halving the size of our sine function. Let's come along down here and we're going to go to number 2 now, which is where we're going to look at our b term. And remember, our b term is talking about a horizontal dilation. So we're looking at like a compression here potentially. So let's say that I compare sine of x again, but this time I'm going to compare it with sine of 2x. So if I compare the one on the left, so sine of x, again, I know that that looks like this, running from 1 to -1, and I know here we're at 180 and here we're at 360. Okay, that drawing's not perfect, but you get the idea. And sine of 2x, well, that's going to be a horizontal dilation. In fact, I'm going to compress this function kind of like a slinky. Okay, I'm going to compress it together by a scale factor of 2. So I don't change the height of anything. I'm still running from 1 to -1. However, this thing, instead of completing one cycle here, you'll see this is completing one cycle in 360 degrees. I now need to get that cycle completed twice as fast to compress this function up. So I now need to get a cycle completed in 180 degrees. So I'm now sort of going to be coming something like this. Okay, and I can fit another one of those into 360 degrees. So you can see here that this function has actually compressed itself and it's going twice as fast. So that's the difference between sine of x versus the sine of 2x. And remember, in our general formula, that is just the effect of changing this b term or this b constant here. Next up, we're going to have a look at what happens if I change c. Okay, and this, remember, this is just a horizontal translation, so moving left and right. So we'll come down here now and we'll do part 3 is where I look at changing the c. And this is just a horizontal translation, so moving our guy left to right. So here we're going to have sine of x, and here we're going to compare sine of x minus 90 degrees. So you can see all we've changed between these two equations is our c value. So I know that sine of x goes something like that. Okay, again, 180 in here and 360 in here, and I'm running from 1 to -1. Now, this part here is just going to be a horizontal translation. I just want to pick this thing up and I want to move it to the right 90 degrees. Okay, so if I compare with my new function, I'm still running from 1 to -1. I'm not changing the height at all. This is only a horizontal translation. But instead of starting here at 0, I now need to shift this starting point to 90 degrees. Okay, so I'm actually going to be starting here at 90 degrees. And this point at 180 degrees, okay, now needs to shift all the way out to 270 degrees. So I'm actually going to be intersecting here again at 270. So what does this look like? Well, it means I'm coming up and down and kind of back down again like that. And you could continue this cycle through if you wanted to. In fact, we can come around to this side like so. So you can see that this here, all I've done is I've just picked my function up and I've just moved it to the right 90 degrees along the x-axis. Okay, and you see that this point here being 180. So that's this point up here at 1, shifting across to my 180 degree points. We've just picked the thing up and we've moved it across to the right. Okay, so that would be the impact of this C value in here. Finally, part 4 is where we look at what happens to D. And I would argue this is probably the easiest one. This is just a vertical translation. So a vertical translation, this is us just picking up our function and lifting it up or down. So for example, we will compare sine of x with the sine of x plus 2, maybe in this case. So all we've done is if you go back and you look at the general formula for that sine function, which I wrote at the start, we're just changing our D value here. So let's have a look at sine of x. So that's this guy here, which does something like that. Again, running from 1 to -1. However, what I'm going to do now is I'm going to pick this whole thing up and I'm just going to lift it up 2 units. So I'm now no longer running from 1 to -1. I'm now running from 3 down to only, so this point here has gone, I've got to +2 to here, and I've got to +2 to here. So I'm now running from 3 to 1. Okay, so my actual function now is going to look something more like this. Okay, so I've actually picked this guy up and I've just lifted it completely above my x-axis here, and I'm now running from 1 to 3. Okay, so hopefully that makes some sense about, like, we're not changing the width or the compression or the vertical dilation or anything like that. All we're changing is we're just picking this thing up and we're just lifting it up 2 units, and that's the impact of changing this D here. What we're going to do now is we're going to come down here and take a look at a couple of multiple sort of examples which should hopefully help tie all of this together. So let's write down our y equals a times the sine of bx minus c plus d. So that's the general formula for a sine function. Now what we're going to have a go at, okay, is part 1. We're going to have a go at sketching what y equals 2 times the sine of x over 2 plus 1 looks like. So we've got quite a lot going on here, but we can break this down into a number of different parts. First of all, we need to do a vertical dilation. So remember this number 2, this A is a vertical dilation, and we need to do that scale factor of 2 units. So we need to stretch everything vertically, doubling its height. Here, my B here is actually equal to 1/2. So I see that I've actually got a horizontal dilation. So this isn't a compression anymore. I'm no longer compressing this thing like a slinky. I'm now kind of stretching it out. So a horizontal dilation of a scale factor of 2, if you like. So I'm doubling its width. Okay, then what I've got to do is I've got to come up here. I see that D is equal to 1. So this is a vertical translation. And I've got to move this thing up 1 unit. So let's see what all of that looks like when we put this into action. So let's draw just my sine of x. So always good to just start with the sine of x. This is the one that you've got to remember. If you can draw this, then you can draw any of them. So this is sine of x running from 180 to 360. I've got my 270 in here, and I've got my 90 degrees in here. Now what we've got to do is we've got to take all of these points here, okay, and we've got to transform them, and we can take each one individually. So let's start with the vertical dilation part. So let's just start by vertically dilating this thing, so making him a lot taller and steeper. We're now running up here from 2 down to -2. But we've not changed the width of anything. So we're still here at 180 and we're still here at 360. So that's this point here done. Sweet. Next up, I've got to try and do my horizontal dilation. So now I've got to actually stretch this thing out because I'm dealing with a half. I'm not compressing it, I'm stretching it. So my period now is going to take twice as long. So I can no longer get a full cycle done in 360 degrees. It's now going to take me 720 degrees to get a full cycle done. But I'm still running from 2 to -2. So I've kind of got to stretch this guy out a bit. So we can kind of see that if I just run this like so, okay, but this point here now is 360 degrees. So you can see that whilst these functions kind of look the same, because I've changed what I've written on my x-axis, they're actually not the same. I've actually taken this and I've stretched it apart, okay, horizontally stretched it, which means here we're at 180 and here we're at, that would be 540 degrees, I believe. So that's our horizontal dilation complete. Next up, we've just got to complete our vertical translation. We've got to move it up 1 unit. So moving it up 1 unit, we are now running the same width of everything. So nothing changes except for my height. I now am running from 3. So I need to add 1 to here and add 1 to here. So I'm now running from 3 down to -1. Okay, and this here still being 180, this being 360, this being 540, and this being 720 degrees. So hopefully that makes some sense, that down here, what I've done now is I've plotted y equals 2 times the sine of x over 2 plus 1. So we're just looking at what have I changed in my A, my B, and my, well, we didn't have a C in this case, but you could throw a C in there if you like, and that D on the end, okay? And you can write down to yourself little notes about what impact that's going to have, which we sort of discovered in the previous video, in the previous section of this video, okay? And then we just take our sine of x and we just apply those transformations step by step, okay, to hopefully kind of create the final answer in the end here. So that's how we can sort of change around our sine equation and be able to plot these sine function transformations.